Good morning, students. We are going to have a review on your inorganic compounds, and that is for the naming and writing of its chemical formula. So before anything else, you should have your periodic table at your hand, okay? So that you can follow. So we have here the prerequisites if you are going to write and name a chemical compound, specifically inorganic compound. So we must have, or you must familiarize with the different charge and name of the different ions. So when we talk of ions, it could be either a cations or anions. And we know that cations are positively charged and anions are negatively charged. Where can we find those? So you're going to refer it in your periodic table, or if you have the list of cations and anions, so you can make use of your periodic table. So in your periodic table, you have here the list of cations and anions, either at the bottom of your periodic table or it's found at the back of your periodic table. Now, in order for you to write, to name properly, correctly, the different inorganic compounds, you must be able to familiarize the different charge and of course the symbol of the different ions. Now, the ions could be either cations or anions. So, again, the ion could be monoatomic ions or it could be a polyatomic ion. So, when we talk of monoatomic ions, so mono means one, so it is an ion that is composed of only one atom. And if it is polyatomic ions, so you have the prefix poly meaning more than one. Okay, so it is an ion that has more than one atoms in it. So we have here example of a monoatomic ions. For cations, you have sodium ion. So the symbol is in A, the charge is +1. Calcium ion, you have the symbol Ca, then the charge +2. Magnesium ion, Mg +2. Take note of this one, iron, then it is enclosed in parentheses 2 Roman numeral, and that is Fe +2. I will discuss this one later. Okay. Now, anions, we have here, take note of the name. The name of the anions, which are monoatomic ions, always end with a suffix IDE. Ide. So if it is chlorine, Cl, and it is negatively charged, that is -1, so it is named as chloride ions. For sulfur, that is negatively charged, -2, it is named as sulfide. For oxygen, as ions and ions, -2 charge, it is named as oxide. We have fluoride, the fluorine, which has a -1 charge, so it is named as fluoride. Take note that the name of the anions, if it is monoatomic, meaning one element only, always end with IDE. Okay? Take note of that one. For cations, if it is monoatomic, the name is just the same with the name of the element in its neutral state, except for ions which has more than one charge. So I have grouped this one, the 3, sodium, calcium, magnesium, and indicated it as fixed oxidation state. So meaning if you have fixed oxidation state, those are ions or elements which has only one charge. So meaning one charge, no other charge. So for example, sodium +1, calcium +2, magnesium +2, no other charge. That is fixed oxidation state. There are cations which has more than one oxidation state or charge, like iron. So that will be discussed here for the variable oxidation state. Okay? Now, for the cations which have more than one oxidation state or charge, the name is not the same with the neutral name of the atoms. So it will be named in two ways: the classical system and the stock system. Okay? So I will just directly mention this one so that there is continuity. So again, monoatomic ions, for example, iron. Now iron has two charges, the +2 and the +3. Where can we get the charge? How are we going to know that that atom or element has more than one charge, or it has a variable oxidation state? You can check it in your periodic table. Mary Michael, can we look at in your periodic table? And everybody should look at their periodic table. Now you can see the oxidation state at the upper right side of the symbol of the element. And you have there the sample. Try to check the location of the oxidation state or valence. That is the charge. Okay, it is found at the upper right side. For example, here, sodium. Check on sodium that is found in group 1A. You look at the charge, it has only one, +1. Okay, no other charge, only +1. Magnesium. Check it, magnesium is found where? It is in group 2A, Mg. It has only one charge, and that is +2. So, elements or atoms with only one oxidation state is termed as fixed oxidation state. Fixed. Okay, so how to name it? You're just going to give the name of that cations, the same with the name of the element or atom in its neutral state. Okay? If the atom has more than one charge, or more than one oxidation state, so they are termed as variable oxidation states. So meaning variable, it will vary, or it could be multiple, more than one oxidation state. So you're not going to name it the same with the atom with only one oxidation state, wherein the name is just the same with the name of the atom in the neutral state. But for the atom which has more than one oxidation state, there are two ways in naming it. You may use the classical system of naming or the stock system of naming, or commonly known as the Roman numeral system of naming. For example, of an atom which has more than one, it has more than one oxidation state. The common one is iron. So look at iron. At the upper right side of the symbol of the iron, you will see there +2 and +3. Okay? So you will see there +2 and +3. Okay? So how to name? You cannot just name it as iron, same with the one with the fixed oxidation state. Because when you say iron, and you know that there are two oxidation states of the iron, you might ask, what iron? +2 or +3? Okay, so to remove that confusion, so it should be named in two ways, whether it's classical system or stock system or Roman numeral system of naming. So the iron 2, +2, Fe+2, the classical name of iron +2 is ferrous. So when we say ferrous, it is understood that it is iron +2. Okay? Or you can name it in the Roman system, Roman numeral system of naming. You just write the name or mention the name of the atom in the neutral state, but you have to enclose that in parentheses, the charge in the Roman numeral form. So if you name it the iron +2, so it should be named as iron 2. Or you're going to write it as iron, enclosed in parentheses, in Roman numeral 2. So that is already understood that you mean the iron +2. Okay? So if it is iron +3, iron +3. So the classical name of iron +3 is ferric. So if we mean ferric, so that is understood as the iron +3. in the Roman numeral system of naming, so you just write the neutral name of the iron, but do not forget to enclose it in parentheses, the Roman numeral 3, so which mean the iron plus 3. Okay? Now, if you are, let's say you are mentioning a cation ion, for example, aluminum, what is the symbol and charge of aluminum? Kindly check it in your periodic table. Periodic table. So you will have there the aluminum that is found in group 3A under boron. So the symbol is Al and it has a charge of +3. Take note that aluminum has only one oxidation state, so it is fixed oxidation state. So when you give the name, it is just named as aluminum. If you are going to write it as aluminum, then you enclose it in parentheses, then 3, that will be wrong. Okay, because there is no aluminum except aluminum +3. Again, to give the name in the Roman numeral system or classical, that is to identify the charge of the atom which has a multiple oxidation state. Okay? So going back here, I have here a note. So most of the metals, so I hope that everybody knows where to find the metals in the periodic table and the non-metals, the separation of the metal and the non-metal in our periodic table. You know that, Mary? No? So you have here if you have the periodic table, you have there actually a zigzag line. So this is a review. So you can see there a zigzag line wherein in this portion you have the boron, you have the aluminum, the silicon, the germanium, the arsenic, the antimony, the tellurium, polonium, and astatine, 80. So basing on the zigzag line, so the ones found on the left side of the zigzag line are the metals. And of course, the one on the right side of the zigzag lines are the non-metals. Okay? The elements found beside the zigzag line are known as the metalloids. They're termed as metalloids. No more ink. So when we talk of metalloids, they are semiconductors because the metals are highly conductors of heat and electricity, and metals are poor conductors of heat and electricity. The metalloids are semiconductors. So these are metalloids except aluminum and what's the other one? Mary, what's the other one? Aluminum and, is it astatine? Is it astatine? So one of these aluminum is considered as metals. The other one is considered as non-metals. Okay, there are 7 metalloids. 1, 2, 3, 4, 5, 6, 7. 7 metalloids. Okay, so going back, so most of the metals, take note, they have positively charged. Most. Only one metal which has a negatively charged. You can check it in your periodic table, and that is only rhenium. Rhenium has -1 charge, then +6 and +7. The rest of the metals are positively charged, or they are cation ions. And the non-metals are negatively charged and ions. Non-metal, for example, chlorine, -1. Oxygen, -2. Fluorine, -1. But there are also some non-metals which has positively charged and negatively charged. For example, sulfur. Sulfur is +4 and +6, so positively charged and considered as cation, and -2. So this one here, the sulfur here is -2 and it is named as sulfide. If sulfur is considered as cation, so it will be just named as sulfur because it has one symbol only. It's a monoatomic ion. So it is just named as sulfur, sulfur 4 or sulfur 6. If it is negatively charged, S -2, so it will be named as sulfide. Same with hydrogen. Hydrogen has two charges, the +1 and the -1. So if hydrogen is considered as an ion, -1, so it is named as hydride. So take note, it ends with IDE. So if it is hydrogen +1, so it is just named as hydrogen. Just like in the molecule water, so it is just named as hydrogen. Just like in the compound or molecule water, H2O, hydrogen here is +1. Okay? Oxygen is -2. Anyway, we are going to study on how to write and name inorganic compound. This one is a prerequisite in the naming of inorganic compound. What else? So we have here the monoatomic ions, and we have also a polyatomic ion. So when we say polyatomic ions, it is an ions which has more than one atom of element in the symbol. For example, for the cations, the common one is ammonium ion, which has a symbol of NH4. Take note, it must be capital N, capital H. It is composed of nitrogen and hydrogen, which has 4 atoms of hydrogen, and it is positively charged, +1. This is ammonium. It is different with ammonia. Ammonia is a molecule, it's not an ion. So NH3 is ammonia. So this is the common one for cations, positively charged. Mostly are monoatomic ions. For anions, we have here sulfate, sulfite. So take note, the suffix here is sol-4. Okay, sol-4. So anions with more than one element in it, you have polyatomic ions. So if the element is, or if the anions, which is polyatomic ions, one of the element in it is oxygen. Take note, sulfate, sulfur and oxygen, sulfite, sulfur and oxygen, phosphate, phosphorus and oxygen, perchlorate or chlorate, you have chlorine and oxygen. Now, if the polyatomic ions, okay, polyatomic ions, one of the element is oxygen, they are termed as oxyanions. Okay, so this one are example of oxyanions. Take note. So you have oxy meaning oxygen. It is an ions with oxygen as one of the element. But we have also polyatomic ions which has no oxygen in it. For example, cyanide. Cyanide is composed of carbon and nitrogen with a -1 charge. Cyanide. Okay? So take note that this one is a polyatomic ion, but it ends with IDE. Okay? Mostly class, if it is negatively charged ions ends with IDE, they are monoatomic ions. Monoatomic ions, it ends with IDE, 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 IDE. But this one, the cyanide, this is not a monoatomic ion, this is a polyatomic ions, but it ends with IDE. Because the polyatomic ions, the suffix, or it will end with either ate or ite. Okay, take note, ha? It will end with 8 or I if it is a polyatomic ions. Mostly end with 8 or I if it is an oxy and ions. Oxy and ions. So, cyanide composed of carbon and nitrogen, -1 charge, but it ends with IDE. Another one, which is a polyatomic ions that end with IDE, is the hydroxide. These are actually exception to the rule. So hydroxide is OH -1. So take note, it ends with IDE. So they are actually one of the exception to the rule. So these are example of polyatomic ions which ends with IDE. We will be discussing this one in naming for a binary compound. Okay? So these are example of polyatomic ions. So take note again. For the oxy and ion, you will notice that it will end with 8 or I. So if you have these two polyatomic ions which has the same element in it, sulfur and oxygen, sulfur and oxygen. They have the same charge, -2, -2. They differ only on the number of oxygen ion. The one with the lower, if there are only two, for example, the sulfur and oxygen, the one with the lower number of oxygen atom will have a suffix of ite. So the one with the higher, if there are only two, it could be only 8 and ite. So the one with the higher is sulfate. So it is named as sulfate. It is named as sulfite. Please take note of the one. Now, another one is polyatomic ions, which is composed of phosphorus and oxygen. Phosphorus and oxygen. So the name phos, so meaning phosphorus, then it ends with 8 and I. Take note again, they have the same charge, -3. They differ only in the number of oxygen atom. Okay, so again, PO4, PO3, the same charge, -3. So the first one with the higher oxidation, first one with the higher oxidation number of oxygen atom, so it will be named as phosphate, 8. And the one with the lower, phosphite, ITE. Take note again, class, because this will be needed in the naming of the acid compound. Now we have here 4 chlorate or polyatomic ions, which is composed of chlorine and oxygen. Okay, and the same, take note, the same charge. You have ClO4, ClO3, ClO2, ClO1. The same charge, -1, -1, -1, -1. First thing that you are going to do is, if you are going to familiarize a polyatomic ions, which are oxy and ions, you have to consider or just familiar the one that ends with 8, the symbol and the charge, the one that ends with 8. For example, for chlorine and oxygen, the one that ends with 8 is ClO3. Okay? ClO3 -1. That is named as chlorate. So if you will have ClO2 -1, so it will end with ITE. It's lower than the less 1 atom of oxygen. So it will be named as chlorite. Okay? Take note, chlorite. Now, for example, if chlorate is ClO3, then it will be higher than ClO3, and that will be ClO4. Still, it will end with 8, but you will have a prefix of per. Meaning of per is higher, higher. So that is perchlorate. Okay? So perchlorate, that is ClO4 -1. If, for example, you know already that ClO2 is chlorite, ITE. So if you have lower than ClO2, and that will be ClO1, so still the suffix will be "ite", but there must be a prefix hypo. Meaning of hypo is lower. Okay? Lower. So it will be named as hypochlorite. Please take note of the prefixes that we are using. The per and the hypo. Hypo meaning lower. Per is higher. Per is higher. That is why you have hypoglycemia. Okay? So, that's it. For example, if you have an oxy and ions which compose of iodine and oxygen. Mary, kindly give me the symbol and charge of iodate. So iodate, you have iodine, okay, iodine, and it ends with 8. So it must be composed of iodine, I, and basta it will end with 8 or I, the other element is oxygen. So it will be iodine and oxygen. And you check on the symbol and the charge of iodate. Iodate is I. It is actually, I do not know if your periodic table or the list of your cation and anion is arranged alphabetically. If it is alphabetically, then it is easy for you to find it out. If not, then some of the periodic table uses they are grouped according to the number of oxidation number. But there are some also that are arranged alphabetically. But in the case of this one, it is alpha. So if it is alpha arranged, it is very easy to find it out. So you just look for iodate. So iodate is IO3. IO3 negative 1. That is iodate. If you are going to write iodide, so take note that it ends with ITA. Take note that it ends with ITA. So the symbol will be less oxygen atom. So if iodate 8 is O3, therefore iodate will be IO2. Okay? And the charge is the same, negative 1. So if we have per iodate, so meaning higher than iodate, so you have per iodate. Actually, if you're going to read this one, means per iodate. Okay? Per iodate, so still it ends with 8, so it is higher than iodate. Higher than iodate, so iodate is O3, IO3. So therefore, per iodate is IO4, negative 1. Okay? So if it is lower than iodide in terms of oxygen atom, so there will be a prefix hypo. Hypoiodide. Hypoiodide. So that will be IO negative 1. So that is how to use the prefixes hypo and per. So you must familiarize the charge and formula of the oxy and ions which end with end with ATE, 8. If you know that one, then you will be able to write correctly the charge and the symbol of the ite, ends with ite, the one with the per blank 8, or the one with the hypoite. Take note, if it is hypo, the suffix should be ITE. If it is per, that's higher, the suffix should be 8. Okay, so this is the video for the prerequisite for the naming and writing of inorganic compounds. So the next video will be naming of binary compounds and the rest of the different classification of inorganic compounds.